All right, CNT125, we're now rolling back into Chapter 8. So the first thing they mention is segmentation. A network can be segmented into physically multiple LANs or logically multiple LANs through virtual LANs. Well, we are going to tackle in this chapter subnetting, which would be like a layer 3 segmentation, and also VLANs, which would be a layer 2 segmentation, just to kind of give you maybe a quick big picture where we're tackling. Either way, the idea behind that is if I break this big network into pieces, I can now have a smaller network where communication is moving around, where I can kind of contain my traffic a little bit. Initially, I have a giant broadcast domain where traffic goes everywhere. As I start breaking into pieces, that area gets smaller and smaller, kind of like fencing in my backyard. If I just let it out, no fence out there, my dogs run everywhere. If I put a fence in, I contain it to my yard. Same thing with my neighbor. If they put a fence, it contains their dog to their yard, and so forth and so forth. Same kind of idea in a network. I'm going to segment to contain. Again, two ways I can segment: subnets, which is basically a layer 3 solution, VLANs, which is a layer 2. We are going to talk later this chapter the idea of typically subnets and VLANs work together. So I'm going to just kind of plant that seed right now. We're going to talk and work with VLANs, we're going to talk and work with subnets, and eventually we're going to put both of those together. As we do labs in our lab room, we'll do some VLANs, then we'll do some subnets, then we'll put them together like we would typically have in a real live network. So they introduced this concept later, but I'm going to kind of plant the seed now. Typically one subnet gets allocated to a VLAN, and that is considered a broadcast domain. Okay, a VLAN is a broadcast domain, subnet is a broadcast domain, but we typically do them all together. So subnet equals VLAN equals broadcast domain. That kind of concept. That's how you're going to typically implement these in a network. So network segmentation, when a network is segmented into multiple small networks, the following occurs. We now start containing our traffic. The traffic in this building is separated from the traffic in the next building. That network then is its own broadcast domain, meaning if a protocol broadcasts, it's still contained in that small area, and that traffic does not broadcast out to the next building, next building, next building, and so forth. So with segmentation, with doing those subnets or VLANs, I'm going to get better performance. My traffic is not affecting other buildings. Secondly, because of that, my traffic is not flowing to another building. My other building can't see this, one building can't see the other building's traffic, if you will. That's going to start helping with security, especially when we make these subnets smaller, where it might go around a group of users or one room of a building, that sort of thing. I'm reducing the amount of people that are seeing this traffic. And therefore, all this starts helping with troubleshooting. If I start seeing errors with a certain, I start seeing lots of errors, and I start looking at the IP addressing, maybe I notice they're all coming from the same subnet. That's going to give me an idea where to start my troubleshooting. When we segment a network, we typically do it by geographic locations, departmental boundaries, or device types. Geographic locations may be this building on campus. Department boundaries may be in that building. There's around this office, that does the finance, and around a different office that does the I should say accounting and payroll kind of thing. One around this office, this subnet or VLAN around this office to contain their traffic, and a subnet or VLAN around a different office to contain their traffic. Last but not least, device types. You might allocate a subnet to the wired desktop users, a different subnet to the wireless users, and a different subnet to the IP phones. And again, that would keep those traffics separated. As we said right here, geographic, departmental, or device type. I just kind of broke that out for you. Well, we want to remember these two concepts when we start talking all this. Collision domain, broadcast domain. And as I like to joke, you're not going to sit around the lunchroom and talk about, hey, how about those collision domains? That's not what you're going to talk about. Or, hey, how about those broadcast domains? That's not what you're going to talk about. But the way the network is set up today is evidence that people have thought about and planned for these collision broadcast domains. So as we look at a network, all of this is already in there, and we have to recognize that. Well, once upon a time, I'm going to look at this part of my network right here. Once upon a time, we used hubs on our network. Well, hubs broadcast traffic out every port. So if I had this whole network over here connected with hubs, when one computer goes to send, every other computer receives it. And because of that, we're all sharing that bandwidth in. Because as I'm sending, you're waiting. As you're sending, I'm waiting. So that whole thing is a big shared environment. That would be one giant collision domain, one giant area where we could have traffic bump into each other. Well, along through time, we got rid of hubs and we started putting in switches like I have over here, all switch network. Well, switches are layer 2. They have some intelligence. They read some MAC addresses, and therefore they try to send data to only one port. So when a chunk of data comes into a switch port, it's trying to send it out to just another device. Meanwhile, this switch over here is doing the same thing. Meanwhile, this switch over here is doing the same thing. Meanwhile, this switch over here is doing the same thing. So theoretically, we're no longer sharing the bandwidth. We're getting full bandwidth to the person we're sending to. So now we have many small collision domains, many areas where we're getting full throughput or full bandwidth, if you will. So collision domains, by putting all these layer 2 devices, we've broken that big area down into small areas where I theoretically don't have collisions. This is a good thing. And that's why our networks today are pretty much all switched. For that exact reason. Again, I'm not going to sit around and go, hey, how about those collision domains? Because we've already migrated away from hubs into switches everywhere. The next part is our broadcast domain. Broadcast domain, when a certain type of traffic goes into the network, it gets broadcast everywhere. Well, switches are not smart enough to stop that. Only something layer 3 like a router, a layer 3 switch, or a firewall, or something like that will actually stop and go, hold on, where are you trying to go? And try to contain it. So in a network like this again, over here, everything's getting, when a broadcast comes into a hub, it's broadcasting all the time. As broadcast comes into the switch is not smart enough. It's going to literally broadcast it everywhere. And the same thing on this side too. Anything that comes in here broadcast, the switch is going to broadcast it out to everybody. Well, putting a layer 3 device up here like a router is going to keep this traffic over here on this side, maybe on this floor of the building, and this traffic here maybe on this floor of the building. It's going to contain those and keep those broadcasts maybe on that floor, or maybe this is building A and building B. It'll keep it in building A as opposed to spilling over to building B. That's what I'm going to get with something layer 3. I need to occasionally put in a broadcast boundary so this traffic does not propagate out through my building into the next building, into the next building, and so forth. Think about Hacks Campus. If there was no broadcast control, a broadcast in, our little Hall Tech building at Harrisburg would eventually creep out to all the buildings at Harrisburg and eventually go across the link down to York and Lancaster and Lebanon, Gettysburg, and it would go everywhere. So my little thing of my computer booting up and saying, hey, can a DHCP server give me an address? That starts getting broadcast throughout, the entire college and across all the campuses. That's just insanity. That should not be allowed. So at some point we need to contain that traffic to maybe a room, a floor, a building, something like that. And that is through something like layer 3 or a VLAN. Layer 3 or VLAN. Layer 3 router, layer 3 switch, or VLAN. And when I do that, I create this broadcast domain. That would be something you might actually talk about in your design of your network. Hey, why are we putting this VLAN here? Hey, why is this router here? Why is this layer 3 switch here? For broadcast containment. Okay? So keep those two concepts in mind. And here they remind us again with segmentation. I'm going to take a large broadcast domain here and I'm going to break it into two smaller ones by doing a subnet, VLAN kind of thing. That's one of the big reasons we are going to do this. And because of that, this traffic over here does not spill into this side. This traffic over here is separated from this side for performance/security reasons. If I have a problem in this subnet, I know to start troubleshooting there as opposed to over here. Okay? The reasons we're going to do segmentation. We'll continue on the next podcast.